This is Mrs. O'Neill for Chapter 5, Review Questions and Problems. Just like in the past, you're going to go through the video by pausing when you see the question or problem. You can do them mentally or write down the answers. Again, I'm going to strongly suggest when you get to a math problem especially, or something you have to draw, you might want to write that down, because the more you write it down, the more it's going to get into your brain. Again, some of these questions are going to be multiple parts, and you're going to continue playing the video and pausing to check your answer. So number 1, answer. And in this video, I'm going to show you again a lot of different visuals, and hopefully those visuals get you even a better understanding. So remember that Bohr came up with the fact that these electrons are on certain paths of the electron cloud, right? He didn't even have an electron cloud. He just said that there are different paths these electrons go on. And now in this particular visual, it says first shell. Remember, we don't like to use the word shell. We like to use the word energy level. And the reason for that is because those energies, those electrons on those energy levels are going to contain different energies, right? So electrons on energy levels contain different energies, and that's why they're called energy levels. But I like this visual because it tells you on each energy level the maximum number of electrons that can be there. And remember, later on in this chapter, we talked about splitting those electrons up into different sublevels. So number 2, again, here's your definition, right? An orbital, in other words, though, is going to be that electron cloud. Where is the most probable place? And remember, we're going to represent that orbital with a box. So 3, then, what is the difference? Can you distinguish the difference? Can you give a good explanation as to why the orbit in the Bohr model is different from an orbital in the quantum mechanic model? Hopefully this makes sense. Again, pause and read it over. So number 4, now we're doing some sketches, and there's a reason for this. First, we want to know the shapes of your S, P, D, and F. So can you come up with a sketch of one S, though, versus a 2S? Is there going to be a difference? Hint, hint, hint. And then is there a difference between the S's and the P's? Hopefully you pause and either mentally came up with that visual or you drew it out. So again, pause and make sure to re-look at this information. Number 5. And again, I've highlighted what you should be looking at, right? I'm looking at orbitals in the p sublevel. Does the 2 mean anything? Not really, because no matter what, in any p sublevel, whether it's energy level 2, 3, or 4, you're going to have 3 orbitals, or those the 3 boxes representing the electrons that can be in there. Number 6. Remember that N represents energy levels. So again, I went even a step further. Not only did I tell you how many sublevels there are, but I told you which sublevels there are: your S, your P's, your D's, and your F's. Now, this is a really, really nice visual. Now, I just, again, like my visuals to show you things. This is part of platinum's atomic structure, and it shows you the 4 first energy levels. So energy level 1, 2, 3, 4. It also shows you how many electrons total are on each energy level, but it also tells you those sub-levels. So again, your light blue here are your S's, and look how nice they even did that. So this would be S, would have 1 orbital, so these 2 electrons would be in that 1 orbital. In your second energy level, you have S's, right? So 2 electrons in your 1s. But if we go around here, you have 1, 2, 3. You have 3 pairs of green because you have 3 pairs of electrons in your p orbital, right? You have 3 boxes, and each one of them has 2 electrons, one going up and one going down, right? Your arrows because of the spin. So I would pause and make sure you visually can understand the first 4 energy levels, how many total electrons, but where specifically are those electrons? Are they in the S, the P's, the D's, and the F's? And again, I really, really like this visual. Number 7. And answer. Again, pause and make sure you're remembering these rules. Number 8. Again, we're ordering in energy, so I put them in order from least energy to most energy, and I also used our alligator symbolization. Again, you're going to see those alligator symbolizations a lot, so I want to make sure you're understanding that this would be low to high. 9, again, which ones are invalid? I'm going to give you a hint that there are more than one. So A, B, C, D, there's not going to be one answer, but there's going to be 2, 3, or 4. And in this case, B and C are invalid. So hopefully this makes sense because there's no D in the second energy level and there's no F in the third energy level. Okay, number 10. So hopefully you paused and actually saw a pattern, and I kind of let the cat out of the bag because I did your S's in your red color and the P's in the blue color. So again, this is going by the sub level, right? It doesn't matter where the S's are, whether it's in 2, 4, or even your 6th energy level, you can only have 2 electrons in an S sublevel. Number 11, you're going to write that configuration. I gave you how many electrons there are and the element symbol. Hopefully you came up with that answer. Again, pause and make sure that your numbers, your letters, and your exponents are correct and in that order. Number 12. So whether you drew this out or you mentally thought, hopefully you came up with that information. Again, you might want to pause and make sure you're understanding wavelength, amplitude, and what a cycle really represents, as well as frequency. So you might want to make sure you know this. I believe on the test, I have you actually drawing a wave and labeling certain parts. Number 13. Again, most of this you already know either from vocab or in your packet, but pause and make sure to read this over. 14. So we're talking about the visible spectrum. So again, we're talking about basically the rainbow. Remember the L's? That's how I made you remember. So you have to just decide, are you going from red to violet or going from violet to red? Okay, so think about you're increasing your wavelengths. Which way are you going to go? Hopefully you thought of violet to red is going to be increasing wavelength. 15. So again, the photon versus a quantum, they both deal with energy, but really photon is light energy more specifically, right? So the light energy that we see in that visible spectrum. 16 is a math problem, so I'm going to strongly suggest make sure you have a calculator out, but you might want to write this down just so you get used to what equation to use if you have to convert any units, writing out the problem using dimensional analysis or again the equation, and make sure you have an answer and a unit. So in this case, guys, you're using that particular equation. So if you did not use this equation, maybe you want to redo the problem. Hopefully you paused, you plugged and chugged, you used your EE button on your calculator, and you used those numbers. Remember, H is Planck's constant, so that's a constant. It's always going to be that same number. So you should have an answer as well as your unit of joules if you did this correctly using that EE button in your calculator. Number 17. Again, when we're talking about absorption, what's going on? So again, pause, make sure to read this over and it makes sense. And then again, I have another little visual here for you. And this visual, again, you're going from low energy to high energy, you're absorbing, but when you're going from high to low, this arrow, this is where you're giving off, you're emitting that photon of energy. So again, here's a nice visual as to just plain old hydrogen. Remember that hydrogen only has one energy level. It only has one electron. However, even though it only has one energy level, again, we have this huge electron cloud, and that huge electron cloud compared to that nucleus means that that electron, when it gets excited, can move up to the second energy level, the third energy level, or the fourth energy level. And what happens is when they come back down, when that one electron comes back down, it's going to give off certain amounts of lights. And that's where you have the atomic spectrum, right? These visual lines, the fingerprints of that hydrogen atom. Because remember, guys, when we're dealing with hydrogen atom, you're never really dealing with one atom, right? We're always dealing with either Avogadro's number of atoms, right? 6.02 times 10 to the 23rd atoms of hydrogen. And that's why that one electron from one atom might go to the second energy level and come back down, so you see the red, but another hydrogen atom's electron will go to the third energy level and come back down in this blue-green. So this is why we can see this visual spectrum, this atomic spectrum, this fingerprint of hydrogen, because it's really never just one atom, right? It's a whole bunch of atoms. So you're talking really about a whole bunch of electrons, because one in each of those atoms. And depending on how much energy is being absorbed from those electrons is going to tell us how much energy is going to be emitted in that form of light. So 18, again, here's your electron configuration. Now you have to come up with the element that it represents. So hopefully, guys, a big hint I've been always telling you is count those electrons. So if you haven't done so already, make sure to count the electrons. Those would be those little exponents. Add them all up, and then you should be able to easily match those numbers of electrons with your atomic number on the periodic table and come up with the elements. So hopefully you got those. Number 19. I've again mentioned that multiple times, right? Each of those orbitals is a box, and in that box you can only have 2 electrons. And remember, those electrons repel each other because they're both negative, and that's why we have the opposite arrows to represent the opposite spins. Number 20 is a math problem. Now I highlighted K here because this is kilohertz. So first you might want to change kilohertz to hertz. So hopefully you did that using your calculator and you got that as an answer. Now we can use the speed of light equals wavelength times frequency. But again, we want wavelengths in centimeters, so be careful of your units. So you should end up with that. So again, pause and make sure that your work basically matches mine. So using kilohertz to hertz there, then using that number to get meters. But again, we want centimeters, not meters. So again, using an equation here as well as dimensional analysis. Number 21. And here's your answer. Again, you can give my answer in 2 different ways here, right? Either scientific notation or long way. It doesn't really matter. They're both the same number. Okay, 22. And hopefully that makes sense. And I found this little visual or this little equation, I thought it was neat. You don't need to know it, but really what it's telling you is that the more accurate you know the position, that means your smaller delta x, that means the less accurate you're going to know the momentum. So again, kind of saying the same thing, but he actually has a equation. So I thought that was interesting to share with you. Number 23. And again, I gave you some hints there with the color coordinating, so hopefully that makes sense. Okay, and again, another nice visual to show you your absorption versus emission. Number 24, another math problem. Hopefully you came up with using that equation. If not, use it now. Hopefully you're using your EE button correctly, and there's your answer. Don't forget your unit. And 25. Again, here's the equation you should be using as a reference. And here's your answer. Remember, you're not going to have to memorize the equations. They will be given to you either on a test or like a reference sheet, but you need to know how to use them and rearrange. All right, guys, we will see you in class. Hopefully you are ready for the test.